Okay, so I'm going to go over just a few of these with you. This is one of the hardest sections, I would say, for most people. So don't be concerned that you're not getting this because it's a difficult concept. All right, so when you're looking at these, the Myopenmath kind of helps you break it down. Normally, like when we teach in the textbooks, I just do straight identity, proven identities, and I don't usually do these, little things like this. But so question one, it's asking you to verify the identity following the steps below. What I would do is go ahead and have your paper that has all the identities on it already written out, so that way you can go back and look. So a lot of times with these proving identities, you want to convert everything so that it has the same functions. Usually sine and cosine are the two that we look at the most. So like this question, it's asking you on the left-hand side, and usually you always work with just one side, and you always pick the most complicated side. So this one obviously is more complicated than this side. And what you're trying to do is you're trying to prove that this side is equal to cosine of x. You're not going to solve an equation. You're proving that this side is equal to that side. And it gives you a step here. Write the left-hand side in terms of sine and cosine, but do not simplify. So how can I write cotangent so that it is in terms of sine and cosine? Well, if you look at your identities, I know that cotangent is the same thing as cosine of x over sine of x. Okay, so if I rewrite that, this is going to be sine of x times cosine of x over sine of x. Okay. And then the next step tells you to simplify. Well, how do I simplify this? This is being multiplied. So what happens to these? There's one on the bottom and then one on the top. So voila, I just proved that this is equal to cosine. So in the steps here, they literally want you to write this sine, and then this one you would need to write just cosine is equal to cosine. So that's kind of how you do those. It looks like you got this one. And let's go to this one. Simplify and write the trig expression in terms of sine and cosine. Same process here, okay? So tangent of u plus cotangent of u. How can I rewrite these so that they're in sine and cosine? Again, you need to go ahead and have all your identities written out so that you can go back and look at this. Well, I know that tangent of u is sine of u over cosine of u. And I know cotangent of u is cosine of u over sine of u. Okay. So now this says 1 over that. So I need to figure out, okay, how can I get a 1 on top here? Well, the way that we do that is we have to add these. And to add these, you have to have a common denominator. Okay. So what is the common denominator between cosine of u and sine of u? Well, it would be sine of u plus cosine of u. So you would have to multiply, not plus, but sine of u times cosine of u. So you would have to multiply this one by sine of u, and we have to multiply this one by cosine of u. And so on the top, you would end up with sine of u times sine of u, which is sine squared of u, plus on the top over here would be cosine of u times cosine of u, which would be cosine squared of u. And then on the bottom here, you have sine of u times cosine of u. And on the bottom here, you have sine of u times cosine of u. Now with fractions, what are we doing when we have the same denominator? We can add these now. So you end up with sine squared of u plus cosine squared of u all over sine of u times cosine of u. And then if you look at your identities, I know what this identity is. What is sine squared of u plus cosine squared of u? It's 1 over that information. Okay, so that's what they're asking you to do on these problems is you're rewriting this so that you're simplifying these so that you are getting the final answer. In this question, question 5 pretty much goes with question 4. What is that function f of u? Well, it's going to be this function right here because these are the same problems there. Okay. So really, you just got to try these problems and practice them. If you get stuck on one, just send me a message. I'd rather you try to Email me any questions, because again, this is a hard concept for most people. So don't be too concerned because you're struggling on it.